Section 8.6, Graphing Linear Inequalities in Two Variables. The objectives of this lesson will be to graph linear inequalities. Graphing linear inequalities has a certain procedure or step-by-step process. The first step is to graph the boundary line, and you're going to use a dashed line if your inequality is less than or greater than. So think about open dot, dashed line. Solid if the inequality is less than or equal to or greater than or equal to. So think solid dot, solid line. Your next step is to determine which side of the line to shade using one of the following methods. Method 1 would be to test any point that's obviously on one side of the line. Then, if that test point makes the inequality true, you're going to shade the half plane on that side of the line. If it's not true, then you're going to shade the other half plane. And whenever possible, if you can put in 0, 0 as your test point, because it's not on your boundary line, that's going to be your easiest test point. If you want to choose another method, then you can solve the inequality for y, as long as you don't have a vertical line. Then your solution would be y less than, or y less than or equal to, which would mean you would shade the half plane below the line. Or if your solution showed y greater than or y greater than or equal to, then you would shade the half plane above the line. I will just tell you I use method 1. If your boundary line is vertical, then you need to solve for x. And then in that case, if your solution shows x greater than or x greater than or equal to, you'll shade the half plane to the right. If the solution shows x less than or x less than or equal to, then you'll shade the half plane to the left. And finally, your solution to to a linear inequality is the shaded half plane. And if your line is solid, any point that's on the line. That's what your solution is. The piece that you've shaded, and then the points on your line if it's solid. If it's a dashed line, it's just the points in the area that you've shaded. So our first example is going to be to graph the solution set to the inequality 2x plus y less than or equal to 6. And the very first thing it's going to ask you is solid or dashed line. I have 2x plus y less than or equal to 6. So solid or dashed, since it's less than or equal to, we're going to do a solid line. And as I said, when you're in the Hawk software, that is the very first question that it's going to ask you. It's going to ask you for that solid line. All right, now I am going to find 2 points on my line. That's the next thing it's going to ask you. I have here 2x plus y equal 6. And that's what I'm going to use to figure out what 2 points are on my line. And I'm going to just choose a couple of values. If I can, I like to find my x and my y intercepts. So the first value I'm going to try is 2x plus y equals 6. I'm going to plug x equals 0 in, which is going to give me my y-intercept. When I plug x equal to 0 in, this value becomes 0, which leaves me with just y equals 6. So my first ordered pair here is 0, 6. When I plug y equals 0 in, this piece becomes 0, and that leaves me with 2x equals 6. When I solve there, I end up with x equals 3. So that ordered pair is 3, 0. I'm going to go ahead and I'm going to graph those 2 points, and I'm going to draw my line. 0, 6, and 3, 0. And then do my best at drawing a straight line. I'm going to redo the line here. We're just continuing our solution. So there's my line. If I go back, my equation was 2x plus y less than or equal to 6. And I'm going to try a test point. So the origin is available, so I'm going to try that to see what I shade. When I plug 0, 0 in, what do I get? That gives me 0 less than or equal to 6. And if this is true, which in this case it is, then that tells me which side of the graph that I'm going to shade. I'm going to shade this bottom part of the graph. My solution then is the graph you see here. So this is what my solution looks like. This next inequality, graph the solution set to the inequality y is greater than 2x. So once again, your very first step is to determine whether you have a solid or a dashed line. Since it's greater than, I'm going to have a dashed line. Now this problem is solved for y. So if we want to use the second method, this is a pretty good time to go ahead and use that second method. In this case, we have y is greater than 2x. And since this equation is in slope-intercept form, I can also use that to graph it. So y equals 2x. My y-intercept is 0, and my slope, m, is 2. So that tells me I cross the y-axis at 0. And I'm going to go up 2 and over 1. Up 2, over 1, up 2, over 1, up 2 over 1, up 2 over 1, down 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 2 over 1. It makes it a little bit easier for me to do a dashed line if I draw the whole thing. As you can tell, I'm not the best at drawing these lines solid and dashed. Since it is solved for y, we're looking for values of y that are greater than 2x, which means that I would shade above the line. So in this case, my solution is going to be this direction. If you're not 100% certain, you can still just pick a value. Although if I were picking a value for this one to test, I would pick something over here because I would like to deal with positive numbers. So I would maybe pick this point here to test, which is 3, 2. So if I plug that in, is 2 greater than 2 times 3? So is 2 greater than 6? The answer is no. So that's why I would shade above it. So that's how it would work if you wanted to use plugging in a point. Example 3, we're going to graph the half plane that satisfies the inequality y is greater than 1. This is one of our special lines. Anytime you have a line and you are missing a variable, that means you either have a vertical line or a horizontal line. So just keep that in mind. Now, remember, first step, dashed or solid. Since it's greater than, we're going to have a dashed line. I'm not able to plug in values of x and y because I don't have x's. But what this is basically telling me is that y is always equal to 1. So if I go in here and I start looking at points, where my y value is always 1? Well, it's all along here, all along this horizontal line. So I plot all those points. Now what you're going to need to enter into the Hawk software, because it wants 2 points. So remember, this is the first question it asks you. And then the second question it's going to ask you is for 2 points. And it doesn't matter what points you pick as long as your y value is 1. So I can do 0, 1, and I can do 1, 1. So those are the 2 points. Of course, I put more than that on there. All right, and then the next step I'm going to do is go ahead and turn it into a dashed line. And then we'll go to the next screen. Here I have my graph again, and I am going to shade again with y greater than 1. I'm going to shade the half plane that's above. This is a situation where, again, it's kind of hard to plug numbers in, but you could try to still plug in one value. So I could still look at my origin here and plug in 0. And is 0 greater than 1? Of course, my answer to this is not true. And so that's why I shaded above it. And here's our example 4. And we have graph the solution set to the inequality x less than or equal to 0. Once again, we have a special line. Now, the last example only had the y value in it, and it was a horizontal line. So this one's going to be a vertical line. My first question always is solid or dashed. Since it's less than or equal to, we're going to have a solid line. And in this case, this is basically telling me that x has to always be 0. So that's kind of awkward to graph because that is actually our y-axis. And the one way that I always remembered whether a line was horizontal or vertical is it's opposite of what you think it should be. So notice we have x equals 0 here, but that's actually going to be on the y-axis, so it's a vertical line. And it's counterintuitive to what you often think. This is a solid line, so I would make it solid. And then I'm going to choose values of x that are less than or equal to 0 to determine what I shade. You still will have to pick 2 points. So similar to the previous example, as long as your x coordinate is 0, you can choose anything you want for y. I will tell you it does have to fall within the window range, so pay attention to what your window range is in Hawks. You don't want to choose like 1,000,000 because it's just fun to do. You want to choose a number that stays within your range. And we're looking for values of x that are less than or equal to 0, which basically means negative numbers, so we're going to shade to the left. And that is your solution set to this inequality.